Everyone. My name is Peter Stakoon. I am a co-director here at Startup Exchange. If you're not familiar with Startup Exchange yet, we are a student organization at Georgia Tech. We're the largest student entrepreneurship organization in the Southeast. We run events, thought leadership talks, workshops, and networking events for our audience, which is Georgia Tech. And now that we're virtual, we have people coming in from around the US and around the world even. We're really excited to bring you PlanetScale here today. This is going to be a slightly more technical event than we usually do, I think, which I'm personally excited for. We're going to start a little bit differently today. We're going to do a quick introduction for everyone in the room right now. It really quick, 10 seconds. So just your name, your major if you're in school, and if you're not in school, what you're currently working on, and then where you're joining us from. So my name is Peter Stakoon. I'm a computer science major right now at Georgia Tech, and I'm joining from Atlanta, Georgia. We'll go down the list here. Jacob?
Hi, everybody. My name is Jacob. I'm also a computer science major at Georgia Tech, and I'm also located in Atlanta right now.
Alan?
Hi, everybody. I'm Alan. I am an aerospace engineering major at Georgia Tech, and I'm coming to you from New Jersey.
Ane?
Hey everyone, my name's Ane. I'm a CS major and I'm coming from Ohio.
Aparoop?
Hey everyone, my name is Aparoop. I'm a computer engineering major and I'm joining from Atlanta.
Virat?
Hi everyone, my name is Viraj Kacker. I'm a first year computer science major coming from Birmingham, Alabama.
Virat?
Hey guys, my name is Bharat. I'm a CIS major at Georgia State University coming from Atlanta, Georgia.
Eric?
Hey guys, my name is Eric. I'm a mechanical engineering major at GT and I'm coming from GT main campus.
Gabe?
Hey yo, I'm Gabe. I'm a material science major here at Atlanta, Georgia.
Johannes?
Is it Johannes?
Hi, my name is Johannes. I'm a literature major in La Salle University.
Josh?
Hey, I'm a part-time MBA student here at Georgia Tech and chemical engineer undergrad.
Mehul?
Hi, I'm a first year CS major and located from Kanpur, India.
Monroe?
Hey, I'm a founder of Virtual Air here in Atlanta, Georgia.
Praneet?
Hey everyone, I'm a second year CS major and I'm from Atlanta, Georgia.
Ram?
Hi guys, I'm a second year biomedical engineering student at Georgia Tech and I'm from Suwanee, Georgia.
Rohan?
I'm a first year IE major and I'm from Dallas.
Sean?
Hi, I'm a second year business administration student from Noonan, Georgia.
Shashank?
Hi, I am from New Jersey. My name is Shashank and I'm a business administration major.
Shruti?
Hi, I'm a second year computational media major from Atlanta.
Siddharth?
Hi, I'm a third year CS major from Atlanta.
Suchet?
Hey, I'm a first year CS major from Atlanta, Georgia.
Vikrant?
I'm a first year CS major and I'm in Atlanta, Georgia.
Yuma?
Hey, I'm a second year CS major and I'm also from Atlanta.
And we had a couple more people join. So Mark?
Hello, I'm a first year computer engineering major and I am from Lebanon.
Beck?
Hey, I'm a third year. Awesome.
Hiren?
Yeah, hi. I'm a first year CS major from New York.
Awesome. And now I think we'll let our speakers introduce themselves. So Dan, would you like to go first?
Sure. Hi, I'm Dan Keselowski. I am the head of engineering at a startup called PlanetScale. It is based out of Silicon Valley. I will let Jiten, who is our CEO, tell you more about what the company does right now. My background is I come from a couple startups. Previous to this, I worked at a large government agency called the United States Digital Service. If any of you have heard of healthcare.gov, they were the team that came in and rescued healthcare.gov. They are still working for the government, trying to make government services better for all of us citizens. Before that, I was with a startup out of Delaware, so definitely not in the startup hub of America. But I come to you now from Saratoga, California, a small suburb of San Jose and San Francisco.
Cool. Jiten?
Awesome. Hey, first, thank you for having us here. It's pretty awesome chatting with so many people who are studying computer science. It's been I don't know, over 30 years since I was in a position that you all are at, but it's kind of nice to see folks at the beginning of their careers and at the beginning of discovering what a cool thing computer science is. My name is Jiten Vaidya. I am the CEO and co-founder of PlanetScale. And before starting PlanetScale, my degree is in chemical engineering, by the way, not computer science. I sort of drifted into computer science because chemical engineering, as those of you, I think I heard a couple of aerospace engineers and so on, it's engineering is mostly math and modeling and programming with some aspects of physical world thrown in. So it was easy for me to drift into computers and computer engineering. I took a few courses at Stanford while I was working at Informix Software here, which was a relational database companies in the early 90s. And I took those courses just because I wanted to learn about computers. I mean, I was programming, and it was good to get some grounding into operating systems and programming languages and so on. So I audited a couple of courses at Stanford, and that's pretty much all of the exposure to formal computer science that I have. I have worked at various Silicon Valley companies like Google. I joined Google in 2005. I transferred to YouTube in 2007. I was one of the first engineers to transfer from Google to YouTube after YouTube was acquired by Google. And I was actually pulled into YouTube by my co-founder here at PlanetScale, Sugu Sugumaran, because he was a employee at YouTube before YouTube was acquired by Google. And we both ended up working at YouTube for many years. And after that, I left YouTube and joined a small startup, which was acquired by Dropbox. So most of my career at Google, YouTube, Dropbox, I have been a backend engineer and a manager of teams. But the small startup that I joined after YouTube, which was acquired by Dropbox, I wrote their Android application. So that's pretty much the only front-end experience that I have. After Dropbox, I also went to Washington, D.C. to do a stint, or as it is called, tour of duty at the US Digital Service. Dan has already told you a little bit about US Digital Service. And that's I mean, we both thought that that was a very impactful way to give back. In general, if you all are not familiar with what is called civic tech, I suggest that you look up what that is and the various things that are going on in civic tech. Basically, there are a lot of problems that our society is facing today. And we as engineers, as people who understand computers, can play a role in solving some of those problems. And civic tech is a way to do that. So just something that I wanted to plug. We started PlanetScale in early 2018. So me and my co-founder, we were thinking about PlanetScale since about late 2016, early 2017. PlanetScale is based on top of an open source project called Vitess. You can go check out the website for the open source project Vitess at vitess.io. And it's what is called a sharding middleware that is used by companies for scaling MySQL. So it scales MySQL by acting as a front end for multiple shards of MySQL databases. How many of you know what a shard is? Have you heard the term? How many of have heard the term shard? Just give me a thumbs up or a thumbs down. All right, so a bunch of thumbs downs, right? So think about a website like YouTube or an application like YouTube, which starts out with maybe a few thousand users, right? And maybe tens of thousands of videos. And you need to save the metadata associated with the users and the metadata associated with these videos. And so you start out by starting like a MySQL server on one box. You come up with a schema, you create some columns, and you start saying, okay, here is what I'm going to create: one row per user, one row per video. Every video is uploaded by some user, so there is going to be a user ID column in the video table, so on and so forth. So this metadata you will start saving into this one database which is running on one machine. Okay, now from 10,000 users you go to 100,000 users. You're all very happy, you're working hard, you need to keep the site up. Okay, you go out, buy some memory, and you put some memory into this box in which your database is running. Your database still continues to work. Fine, you are doing very well. Now you have 10 million users. Okay, now this server, you have upgraded it to $100,000 machine. Okay, it's serving queries for 10 million users, and you think that you are okay for the next few months. Now you are at 20 or 30 million users, or you are at and you know that in 3 months time you are going to be at 100 million users, because you can see that hockey stick graph, and you can see the rate at which your usage is growing. So there is no way in which all the metadata associated with all these 100 million users and a billion videos that you would have at that time, or tens of billions, who knows, right? It cannot fit physically on this one box. You can buy a 16 CPU box with really fast disks, a lot of RAM, and so on, but still this database is not going to fit on that one machine, right? So what do? So you take the same schema and you apply it to two databases. You copy the rows for half the users from this database into another database. And what you have done is you have sharded your database into two shards. Okay. Now, when I explained this to you, I made it sound easy. Yeah, you buy two machines, you start two things, you apply the same schema. But keep in mind that you have to do all this while millions of people are watching billions of videos. You don't want them to take a downtime. You don't want to bring your site down while you are doing this, right? So you want to do this resharding exercise while continuing to serve traffic. And we did this. And okay, now there is also your application that is talking to this database, right? Before you sharded, your application was pretty simple. You just created this one connection to the backend database. You wrote using that connection, you read using that connection. End of story. Now that you have two databases or two shards, you need some logic in your application which says, oh, let's say that there are 100 million users, 1 to 50 million in database 1, 50 million to 100 million in database 2. If user ID less than 50 million, use this connection. If user ID greater than 50 million, use that connection. Okay, what happens if you are running a report where you don't have user ID, where you just say like, give me the top 10 videos that were watched last hour or something like that, that kind of a query. You send it to both databases, get the results back, you do some processing with the result sets from both databases, and then you give the answer back, right? So you're adding complexity in your application by sharding your databases. So that's the problem that Vitess solves. What Vitess does is that Vitess sits between your application and these multiple shards that you have created, and gives your application the view that it's talking to a single monolithic database. And all the sharding complexity is encapsulated in Vitess, right? And so think about it, the Vitess has to be a generic database-like layer that can work with multiple types of schemas, multiple types of data, right? It can't just say that, oh, I know about user, I know about video. It basically needs to work with any kind of database, any kind of schema, any kind of application. So it basically has to mimic a database in many ways, right? So Vitess supports the MySQL binary protocol. Vitess has a full MySQL parser built into it. And when, for example, a query comes, like show me all the videos watched by, all the videos uploaded by user ID blah, it looks at the value of that blah, figures out which of the 256 backend shards the user blah corresponds to, sends the query to that shard, gets the results back and sends it back to the application. So that determining which shard the query should go to, sending the query to that shard, getting it back. So query routing is all built into Vitess. Not only that, all kinds of other operational things are built into Vitess, which make it easy for you to go from 256 shards to 512 shards. So that problem that I described, that when you go from 1 billion users now to 2 billion users, when you want to increase the number of shards. So at YouTube, we used to do something, an exercise called capacity planning. You sit down, you look at the resources that you currently have, you look at the rate at which you're growing, you say, what will I need 3 months from now? And you say that that's the capacity that I'm going to go to, so that I have capacity enough 3 months from now, given the current trends, right? So support for all those workflows was built into Vitess. And because of that, Vitess is today used by companies like Slack, Square, GitHub, Twitter, Airbnb, Etsy, a Bloomberg, and a few more that I'm forgetting. Roblox. I think you all are probably a little too old for Roblox, but your younger siblings probably know what Roblox is. So Vitess is pretty well known. Vitess is a pretty battle-tested technology, and what we are building at PlanetScale is a world-class database as a service on top of Vitess. That's the reason for PlanetScale's existence, right? So since this is an entrepreneurship chat that we are having, there are a couple of different ways in which open source projects can be monetized. One model is what is called open core, right? And open core is you take an open source project, you add some enterprise features on top of it. Typically, the way companies think about it is that open source functionality is usable for a single user, and when you add functionality that is useful to teams, you typically keep that functionality closed source and you charge enterprises for that extra functionality. So there is an open source core, and on top of that you build enterprise technology which is closed source. And what you license and support is this closed source, open core plus closed source layer software, right? So that's called, that type of business model is called open core business model. The second type of business model, which has really seen traction over the last 5 to 6 years, is running this open source software as a service in the cloud. And one sort of shorthand way to refer to this business model is open cloud, right? So think about GitHub. Think about Amazon's database RDS MySQL, right? Or think about Databricks. Think about Snowflake, right? All of these products take a software. I actually don't know if Snowflake is open source or not. They may not be open source, but there are many companies today who take an open source project and build a really, really great user experience around cloud hosting of this open source product. Make it really easy to use it for end users, because typically these open source projects are complicated distributed systems, and it takes operational toil to make them easy to use. So you take that away, you host it in the cloud, people can swipe their credit cards and start using it. And that's exactly what we are building. And that's what we have built at PlanetScale. You can go to console.planetscale.com, create an account, get a connection string, and you can start using it. So I think that went a little longer than I had expected I was going to go, but that's what we are doing at PlanetScale. So I'll stop here and we can now jump into questions. Thank you.
Yeah, that was a great explanation. Thank you. So to address the audience for a second, this is going to be a much more discussion-driven event than we usually do. So if you do have questions, please feel free to unmute yourself and ask away. You don't have to send your questions in the chat or raise your hand in any way. Just feel free to keep the conversation moving. And with that, let's kick it off. If you have any questions, feel free to ask them now.
I have a question. Could you describe what the process was like for you to start coming up with the idea of this solution, and then like actually creating it? Did you have to pivot along the way? What was that process like?
So in some sense, we are still, refining what we are doing and how we are going to market and so on. And for a startup, until you start seeing hockey stick growth, that process never ends. But maybe Dan, do you want to speak about how we went about building our V1?
Yeah, I was going to say, I mean, it's a really, one of the things that I love that we did at PlanetScale is actually before the company was even formed, just before you guys had even gotten I don't know where you guys were in the fundraising at the time, but I know that we had a potential customer, somebody who was a user of Vitesse. They wanted to have a commercially supported product. And so they came to us and said, hey, we want you guys to help us run Vitesse. They were users of it. They had done it manually. They figured it out themselves. And they said, well, we want you guys to help us. And at the time, I don't think we were at that point completely sold on the service model, right, Jiten? Yeah. So we weren't completely sold on the service model. We're kind of figuring out, are we going to license? Are we going to have a service? How's it all going to work? Sat down with a customer. I think I can say their name. If I can't, just everybody pretend I didn't say it. So we sat down with Square Cash, and Square Cash said, we run your thing. We're going to be moving into a different data center. We're going to be moving to the public clouds, and we kind of want you guys to help. So what can you give us that will help? So we said, all right, well, we can help you run this thing in the public clouds. After talking with them, we decided that we could make them a Kubernetes operator. They were moving to Kubernetes. At YouTube, Vitesse ran on Borg, and Borg was the technology that predated Kubernetes. So we already had this world-class product that had a lot of experience running in a very chaotic environment. One of the calling cards of Borg, Kubernetes, or cloud native systems is anything can fail at any time for any reason, and nobody should know about it, right? So the Vitesse, the open source project, already had all this support built in for things like unplanned failures, for cycling hardware. And so we said, okay, well, we can build the orchestration that will work for you in Kubernetes. Well, it turns out once you have that in place, so we did. We sat down and we built out a tool that would actually run Vitesse inside of Kubernetes for this customer. And they started running it. And in the meantime, we had said, we really think hosting this for people, the community told us over and over and over again, if we went to the Vitesse Slack channel and said, what do you need from us? They would all say, it is way too hard to run this thing. We just want an easy way to run it. In fact, I think they still tell us that. So that's when we said, great, we'll just put up a service. You click a button, you get a database. And so we had this software project that we had been working on with this customer that you could, given a little bit of information, you could provision and manage a database. So that was really the place that we started going down. And we said, all right, we're going to run this service. We're going to build it off of Kubernetes. And, the initial thesis statement that we have is, if we can make it easy for people to come and get a database that will scale to YouTube size, right? Literally the biggest website on the planet. If we can just give them a button to press and to get that, that will be a valuable product for people. Let's go ahead and do that. And so working with a customer, working with our community, that's how we put V1 out.
Yep. And I'll take the story a little further after that. We put that one out, and that's when we started looking for our Series B funding. Actually, we started looking, sorry, not Series B, Series A. The time frame that Dan is talking about was when we had only raised a Series Seed. And this running it as a service was the story that really resonated with our Series A backers. And the reason that we started looking for Series A was because we were already seeing some inbound interest for raising for the next round because of the CNCF. So the open source project Vitesse is something that was accepted by the Cloud Native Computing Foundation, and by now we have graduated. But the Cloud Native Computing Foundation is a pretty sort of good, a good seal to have, and that brought us onto the radar of a whole bunch of people. And that was like one offshoot of that was that we started seeing some inbound interest, and so then we sort of started talking to VCs saying that, hey, here is where we are, here is what we have built, here is what our plans are. We weren't actually looking for the next round, but we are seeing some inbound interest. Are you interested in it? And that's how our Series A round came together. And Peter Levine from A16Z, he really liked the approach that we were taking. And he's somebody, I mean, after he invested in us, you should look him up. I mean, he has done a really great blog post and a talk around this open cloud model and how this is sort of the 2.0 of monetizing open source projects. So it really made sense to him, and that's how we ended up raising our Series A from Andreessen Horowitz. Cool. Any other questions?
Yeah, can I ask a question real quick?
Yeah.
When you're in the bootstrapping stage as a startup, you're definitely trying to scale up your server or the power of your company. Is there like a kind of tried and true strategy for transitioning from maybe a bootstrapped in-home hardware server to a cloud server? And is there like any sort of pricing structure related to down the road, how much cloud space or speed you're running to make it function?
So when you are early, all the scale of the problems is really small, right? uh, and what you're worried about, if you have a scaling problem when you are bootstrapping, you're already winning, right? Because that means that you have product market fit. um, Typically the way this works is that by the time it becomes a quote unquote real product with real uh, customers, the size of your database and the availability guarantees that you need to give those customers and so on are low enough that you can take a dump of that database over a weekend, upload it into some cloud provider, hopefully PlanetScale, and have it up and running in your new environment without too much of a trouble, right? It's only when so the analogy and one thing that we used to talk about at YouTube is that changing an engine on a airplane while the airplane is flying, right? It's when you are in that kind of a mode that you really need some of these tools and so on. So actually, I'll give you an example of a company called community.com. I mean, as entrepreneurs, you should check them out. I mean, it's an interesting business model. So what they do is that they have a platform where brands and celebrities can engage with their followers using text messages, right? So that the celebrities, influencers, brands, etc., are not dependent on a specific platform like Twitter or Facebook or whatever to communicate with their followers. They can directly reach them using a text number that their followers can text them to and that they can text them back. Venture-backed company based in Southern California, they are using our database as a service, even when they really don't need the scale that we can theoretically provide them, right? But the reason that they're using this is because when they come out of stealth, for example, 2 weeks ago, they were in the news because CNET, Barack Obama started using them as a platform for engaging with his followers. So the reason that they used us is because they wanted the guarantee that when it comes time for them to scale, we will scale with them. And so they wanted to choose a technology so that they can start right. Their spend today is not very high, right? Because they are not, they don't have that much data, they don't have that much traffic, but they have the guarantee that the day they have like 100 million users or 200 million users, they will still be able to scale with our technology.
Thank you.
Let me ask you another question to clarify a little bit. Are you specifically talking, is there a specific technical area that you're thinking about more than others? Because this answer is going to change really based on, is this a very hardware specific specialty hardware system like GPUs, machine learning, special silicon?
So we have to we're Virtual Air is a hardware software and SDK company. So we're kind of building the engine and putting the seats in and all the above at the same time, like that analogy. But we do a lot of 3D modeling, or 3D modeling in VR that has to be converted to a file that can be 3D printed and can be prototyped and then tested. And then there's a software that has to run the hardware and the firmware, and it's all of it. And it's like sometimes we just need a really powerful farm server to render like files or an animation. But other times we just need to make sure our stuff's reliably backed up. So, that's why the conversation started outside of this too.
This is a tough, I mean, so what you're describing there is a very tough thing that I've seen a lot of startups and even big companies have a problem with. This isn't limited to startups, right? You could be a Fortune 10 company that has a ton of hardware on site, but you need that like burst, or you need somebody not hands on a keyboard to get you off of your current systems. There's two bits of advice that I would give you. One is if your system is not built like cattle, you're going to have problems. and Jiten was alluding to this a little bit, of that if you're picking components for your system that are one-offs, like I have my server under my desk and it just works, and I just type commands, commands into the terminal and stuff happens. It's going to be a difficult process no matter what. Everything really does need to be software defined, and all of your components need to be proactively selected from the beginning so that they can make that jump to run anywhere. One of the things that what I would now preach to you as the tried and true method, would get me yelled at on Hacker News, but you should build off of something like Kubernetes. You can run Kubernetes on your laptop. You can run it on your desktop. It's got support for GPUs. You can also provision a cluster in the cloud. One of the things that we wanted to do, one of the use cases we had for PlanetScale was you can actually run our database across Kubernetes clusters, so that as you're, specifically to help people with this problem, if you are running your system on a server in your co-located facility or a server on your desktop and you want to take it to the cloud, we provide the pipes to make that happen. So we've seen lots of people do it. It does in fact work. It is how I would recommend you get started. Pick your components from the beginning to not depend on any single physical piece of hardware or single vendor, and you should be pretty good to go from there.
Awesome, thanks. This is my first PC build because my dad used to work on Macs as a graphic designer, so wish me luck, everybody.
Go AMD. AMD Ryzen 5000.
Hey, I have a question about, I guess, early stage startups and your thoughts on balancing spaghetti code and like duct tape together code just to make it work versus thinking about scalability and taking that time to make something that really you can guarantee will work in the long run.
So this is it's a very interesting topic in general, right? And I mean, I think of it in terms of entropy, and this is something that it's not even applicable to just code and startups. It's applicable to life in general, right? Like, there are ways in which you live your life that generates that generates clutter, that generates things that you should spend some time cleaning up. How frequently should you do that cleanup, and what's the best way to deal with that is a more general way to frame this question. The way you should think about it is that as a startup, your job one is to find product market fit. Anything that gets in the way is superfluous. So you should be very clear about that. But you should also keep in mind that there are certain things that if you just do them a little more mindfully, they make it easy for you to not generate clutter. So don't do it the dirtiest way, that the first thing that comes to your mind. Do give it another minute's thought about, is there something that I can do so that it's not going to take me longer to actually implement it, but it wouldn't be quite so ugly, right? So because many times just doing things a little more thoughtfully does give you a better long-term property without compromising the velocity of execution. So I don't know whether that was a useful answer or not, but that's how I think about it.
Yeah, Yuma, I can share a story with you about that exact topic. Company that I was with 2 companies ago called Sev1, we did network performance monitoring. So nowadays, if you are building systems, you may have heard of companies such as Datadog or New Relic or SignalFX. We were building a product that was sort of a data center centric, used by a lot of big telcos. And we were a young startup. I want to say almost everybody on the team was fresh out of the University of Delaware. We hired pretty much the entire graduating class from the University of Delaware for about 5 years. So we didn't really spend a lot of time thinking about making really well architected code. We wanted to make really fast code, and we wanted it to fulfill our customers' needs right up front. And that actually worked for about 2 years. We became really successful. And one day, Verizon Wireless was using our product, and they were rolling out their 3G LTE network across the whole country. We were selected as the vendor to provide monitoring. It was a huge success for us. One of the things that happens in startups is you can actually become overly dependent on a single customer. So at the time, we had around $60 million a year in revenue. Of that, 40 million was Verizon Wireless, right? So it's like existential to the company that this customer is happy. We had some spaghetti code there, and it failed in spectacular fashion in Verizon's data center. And what ended up happening is we had to put a team of around 20 people, stopped everything at the company for 8 to 9 months, and had to put a team of 20 people to fix that spaghetti code. It's partially the reason why today I say you've heard of Datadog and not that you've heard of Sev1 Data Cloud, because during that 9 months, there's other people out there who are working as hard as they can to eat your lunch. So the balancing act isn't even so much, race to get product out there. It will slow you down if you do too much spaghetti code. You do have to do things so that you can move quickly for an extended period of time. Never lose track of that. If you're doing something which today is going to get your code out faster, but in 6 months is going to slow you down, in 6 months, if it slows you down, that could be the time that it takes for a competitor to come and actually win those accounts, those deals that you're trying to win, because you can't innovate down the road.
Thank you for that. It's very helpful.
I actually have a question. Where do you guys see the kind of next stage of databases going, kind of in the context of newer players in the market like Realm, which Mongo recently acquired, and then companies like Rockset who do more just like really hard indexing? Where do you see that direction going?
So I'll talk about Rockset. So when you think about database market, you should think about two different segments and two different use cases, right? So one is OLTP, which stands for online transaction processing, and the second is OLAP, which stands for online analytics processing. And online transaction processing are databases like MySQL, and it's basically any customer-facing app. The data that is used by any customer-facing app is the online transaction processing kind of data and online transaction processing kind of queries. OLAP is that the data can be the same, but a product manager who's trying to find insights, or a business analyst who's trying to look at trends and find, how I can save money, et cetera, by combing through the same data, would run OLAP kind of queries, right? So Snowflake, Redshift, even Rockset, they all do the OLAP databases, right? And Rockset is quite clever in what they want to do. So if you think about how these OLAP systems work, they take the data from the OLTP databases, so the databases that are being used for giving the user experience as users are using these applications. They export that data into backend databases where it is saved in different formats, in different ways of, and these exports typically happen maybe once a day, maybe once an hour, maybe once every 15 days. So the fastest this export happens typically is 15 minutes, right? So these insights are at least 15 minutes stale. What Rockset does in turn is that it sort of has this has the data from your OLTP system streaming out into an OLAP system with, I think they talk about 5-second latency, so that the 15-minute delay is now brought down to about 5 seconds. And what they do is they take this data, and for every column they build indices. They create three or 5 different types of indexes on every column that is being used, and that is how they allow you to run really fast queries on with really small latency compared to what's happening in the OLTP world. I think it's a very clever solution, slightly different domain, and not one that we directly compete with. Realm, I'm not familiar with. Dan, have you heard of Realm?
I haven't, but I imagine if they were bought by Mongo, they're probably living in the same space. Um, I have thoughts on this topic.
Yeah,
So
please go ahead.
the future of database, whether it's Realm or Rockset. So I just looked up some numbers real fast, right? In 2010, the best CPU on the market, right? Absolute best CPU on the market had a CPU bench score of 13,000. Today, the best CPU on the market has a bench score of 81,000, right? Amazing progress. 6x performance in 10 years. Well, I mean, the problem is the number of internet connected devices, the amount of people who are using the internet has gone up by a lot more than 6x in the past 10 years, and it's going to continue to go up. I remember another story. Me, Jiten, and some other people, we were doing a meetup in Beijing, Shanghai. It's one of the big cities I think it was Shanghai. In Shanghai, China, we were at a random WeWork that we got plugged into to do a meetup, and we met some entrepreneurs there. And we're talking to them, and they had a very small business. It was only located in Shanghai. It was only servicing the people of Shanghai. Now, like Shanghai is a city of like 50 million people, so that's pretty big. But they could not store their data on a single database. What I see the future being, and we have talked to numerous companies, kind of in the nature of our business, we've talked to numerous companies that if today you were building your application the way you built it in 2010, it's not going to work. The idea that you can store your stateful data on a single database is just wrong. So it was already a problem in 2009. That's why MongoDB came around. It's web scale. It doesn't use joins. So what we're seeing is at the time, Sugu, the co-founder, would tell you how when they were evaluating what to do, they looked at Mongo and they said, there's no reason why you can't do this relationally. Your data is relational. We can bring that power to the data set. We just got to do things right up front. That's only going to continue as time goes on. The nature of data hasn't changed. It's still relational. We're still spending a lot of time and money to exploit the relationships between our data, but data sizes are growing even bigger. And so looking forwards, one of the ways Rockset is built is they sort of separated storage from CPU so that they can scale each one independently. A couple companies have done this. Amazon did it with Aurora. Snowflake did it. Rockset is doing it. Anybody who says they're doing serverless databases, they're doing the same thing. They're separating CPU from storage. Well, Vitesse, we did it in 2010, right? We were kind of streets ahead at that point. That's where the future is going to be going. We're going to see databases being decomposed. We're going to see data that is going to be living differently from where the other portions of the server are. All of the distributed databases that you know and love, so Vitesse, which you all know and love, things like CockroachDB, things like TIDB or Yugabyte, they all have these architectural models where they have split the storage from the query processing and the query handling. That's going to be the future. That's what you're going to see as time goes by. You're going to see decomposed databases that are built to scale to actually handle the data workloads that we have in the future.
I have a quick question going back to a little bit earlier. You said a lot of interest was kind of built up around Vitesse after it got like national recognition, and then like subsequently you got a lot of inbound interest from investors into PlanetScale because of like the interest around Vitesse. Outside of just like the fact that there was a lot of inbound interest in like from Vitesse, could you kind of walk us through your kind of like your thought process into giving up equity for multiple rounds of funding, and like why you went through those multiple rounds of funding?
Right. So a couple of things, right? When you raise a round, a lot more is happening apart from, you giving equity in return for cash. Okay. Like for example, take a look at this, our seed round. So our seed round was, done by Signal Fire. We raised $3 million from them. But they actually put in something like $1.8 million. The rest of the 1.2 million came from sort of a who's who of the CTOs and people who know and understand scale, right? So one of the investors was the CTO at YouTube, Steve Chen. One of the investors was the founder of Quora and the CTO at Facebook, right? The VP of engineering at Dropbox was an investor. Max Lovchin, who is a founder of PayPal and founder of a firm, was an investor. And so there is a story to be told around it, right? And the reason that we wanted them in our round is because it validated our technology. It validated us as a team. It validated, it signaled to the market and to the other investors that these people who actually have faced these scaling problems believe in this technology, believe in this approach, and are willing to invest in us, right? And I mean, anytime you are hiring an employee, giving away equity, or taking investment from an investor, you have to think in terms of the size of the pie, right? Does bringing this, so I mean, there could have been different ways we could have gone, right? So when we decided to raise our seed, it was me and Sugu. We could have decided that we are not going to hire anybody else. We are going to fund development for the next 6 months or a year or so on our own savings, and built out some, built it out to a level where we could have gone and gotten better terms. All of that was definitely possible. But we were already on top of this open source project, Vitess. We already had people like Dan, whom we would have wanted to join us. And Dan needed to move from Washington, D.C. with his family to the Bay Area. We would not have been able to pay him a salary from our savings, right? So taking that money, bringing Dan in, accelerated the expansion of the pie, right? That's how to think about it. So that's why we did the seed. And same thing with A16Z, and A16Z particularly because they are a marquee, tier one venture capitalist, and two, they have this model where they have about 80 people. So all of you should do some reading and understand how venture works, how venture capitalists work. I mean, before I raised our seed and Series A, I had no idea what the incentives of the VCs were, how they work, and what motivates a good VC. You hear all kinds of stories. I mean, like everything else, there is a bell curve where there are a few very terrible ones, there are a few great ones, and most of them sort of fall somewhere in between, right? So it's kind of good to understand what motivates them, what the structure is, what limited partners are, how VCs themselves are compensated, and what it is that, when you talk to the VCs, you are one of the 50 meetings that they would have that month or whatever. I mean, pick a number depending on who you're talking to. And you have to, I mean, finally, it does all come down to people that you're talking to, because everybody, a lot of these decisions end up being fairly subjective decisions, which are based on that person's specific background, the chemistry between you and that person, and what you present, how you present it, what your thesis is, and how much they believe your thesis. So, to some extent, these things can be data driven. To some extent, you can think about various ways in which you can present, but it kind of, in any conversation or in any discussion, it always helps to understand the point of view of the person sitting across from the table from you. And that's why you should learn and understand about the venture market, and how they function and what their priorities are and why they are sitting across the table from you. I mean, that's something that I really needed to learn. And you learn it as you talk to multiple people, as you present your deck, as they say no to you, and so on. You sort of refine your understanding of this whole landscape through that whole process. But A16Z, as I was saying, specifically, they are a firm where they don't just have the primary partners and their support staff who are talking to entrepreneurs, deciding whether to make investments or not and writing the checks. They also have a separate department where they have about 80 people that they hire who are sort of professionals at the top of their field in marketing, in recruiting, in sales, in corporate development, right? So, and that stable of 80 highly qualified people who have seen startups, who have worked at startups, who have seen them grow, who have seen them scale, their expertise is available to you as a founder that A16Z has invested in. And more VCs are kind of following that template now. But that's particularly what attracted us to A16Z. And for a company like ours, where both me and my co-founder come from engineering backgrounds, and this is the first company that we have founded, having that kind of expertise at our disposal was really important. So you think in terms of dilution. You have to think about what matters is increasing the size of the pie, because there is no point in having 90% ownership of something that is going to be worth $100,000. It's much better to have 50% ownership of something that's going to be worth $1 million, right? Dan, you wanted to add something?
I mean, there's two things that surprised me around Andreessen Horowitz. One is that they were just the money. More than just the money was that they actually, they do have a lot of support staff to make the company better. The second thing that surprised me was how much they wanted me to spend that money as quickly as I could, which was shocking to me. I was in Pittsburgh with some Andreessen Horowitz staff, and they were encouraging me to buy ice cream for everybody. I'm like, this is your money. And they were like, yeah, spend it all. We'll give you some more. There's nothing that they would like to do more than to give us more money for more equity. They're in the business of gathering equity, and that's really what they want to do, especially in companies that they love.
Thank you. That was a really refreshing perspective on fundraising. Thanks.
I know we're just over 6 o'clock here. So Jiten and Dan, if you guys have anything else you want to leave the audience with before we wrap up here.
So I just wanted to mention one thing, so that, thinking through what is going to differentiate yourself from the competition, thinking through what is it that is missing in the market and that you can build so that you see that hockey stick growth. That is something that you have to continuously keep on thinking about, and we are thinking about it. And we are going to come up with some amazing features over the next couple of quarters that make our database as a service leaps and bounds better than what anything that the cloud providers currently have. So those of you who are engineers and are thinking of building things, etc., or have engineer friends, keep checking what we are doing. I think you'll have things to see that will blow your mind. That's what we hope. Dan, you want to say anything?
Yeah, my parting words would be twofold. First would be, if you're in college still and you're thinking about startups, the advice that I would give to you is almost all startups fail. Almost all of them do. You're not going to get rich quickly. If you are in this to get rich quickly, you're going to have a bad time. That being said, building companies has been the most rewarding thing that I have done. I have chosen it instead of going to big companies because I get a lot of value out of it. Be in building companies because it is what you want to do, not because you are trying to get rich quick. You're going to have a much better time. second word of advice that I would leave you with is even the most successful people that you see did not do it by themselves. Get yourself a good set of advisors, get yourself people that you trust, surround yourself with them, and listen to them. Things like this, forums like this, where you can listen to people like Jiten, who are CEOs who are living it, you know, get all the advice you can, surround yourself with good advisors. That's what I got.
All right. Thank you both. Everyone, we appreciate you coming out. That was a great event. I really like the technical nature of it. Personally, I think this was one of our best yet this semester. So everyone who came out and listened, thank you very much. Thank you to everyone who asked questions. And thank you, of course, to Jiten and Dan. Everyone have a great Friday night.
Thank you for having us. We enjoyed it too.
Stay safe and stay socially distant.
Yep. Have a good weekend.
Everyone.